Hello and welcome. I'm Tarmo Ramel, and I'm here this week to tell you a little bit about permutations, combinations, and how to implement those in Excel. So I've taken the liberty to put some things into this week's workbook. So you can see there's already stuff behind me. Above my head there's a padlock from somebody's briefcase. I mean, who walks around with briefcases anymore? But the idea is that there are a series of dials and you can set those to a combination that will allow you into your case. So let's try to avoid confusion with language, and rather than call this a combination lock, we'll call it a code. We have a 3-digit code that unlocks our briefcase, and we're probably familiar with these things. We can take the little wheels and we can roll them up and down and set them to a very specific code that we have previously set. So the first question that comes to mind is, how many possible codes can these 3 dials actually contain? There's not a huge amount of thinking that goes into this. We've probably figured this out before, but I've written the question out here in cell I3. It says, how many possible codes are there? Well, to figure this out, we need to know what the space or the sampling space is, and we can look at and rotate each dial through each possible case that it might show, and we see that each possible dial has values 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and that means that there are 10 possible values on each dial. We know that there are 3 dials, so we can write out dial 1, dial 2, and dial 3, and each has a maximum possible number of settings that it can take of 10. So if we take the first dial's total number of possibilities and we multiply it by the second dial's total number of possibilities, and we multiply that result by the third dial's total number of possibilities, we end up with the total number of unique codes that those 3 dials can hold. So if I click on this cell, M14, we can look at the equation in the formula bar, or I can double click on it here, and you can see it's K10 times K11 times K12. So it's simply taking these 3 values and multiplying them together, and we get 1000. So it doesn't take too much thinking to say, well, I've got 3 digits and I set them 999, there's 999 combinations, and if I rotate them all to zeros, I have one more, so there are 1000 ways that I can have some kind of a code on this briefcase. Now somebody might have rules on how you set codes, and they might say, well, what if you could only use any number once? So if you're setting your secret code and you decide to use a 7, you can't use the 7 on more than one dial. So which means that on dial 1, we have 10 possible values that that dial can take. But once we set it to some number, that number can't be used on the second or third dials. So on the second dial then, there are only 9 possible selections that can be made, and on dial 3 there will be 8, because 2 will have already been used on the first and second dials. So we could take those 3 values and we could multiply them out, so the total number of codes would be 720. If I double click on there and I expand it, we can see that it's P10 times P11 times P12. 10 times 9 times 8. So the important thing here is that order matters. We can't assume that simply because we select the numbers 5, 6, and 7 for our secret code, that they're going to open the briefcase if the code was originally set at 5, 7, and 6, the same digits but in a different order. So the order here matters. So we can use what are called permutations that allow us to get at this value really quickly. So we write this out as lowercase 10 subscripted, large P, lowercase subscripted 3. And it basically says, let's take 3 numbers from the population of 10, but order matters, and it's going to figure out how many unique permutations there are of numbers that we can select. In this case, there would be 720, because we can't reuse numbers. So this really does make a difference. But there are other ways that sometimes this kind of thinking creeps into our lives. So I'm going to click on the second tab. It's currently behind my back, but if I quickly turn myself off, we can see that we've been on the Permutations tab, but if I click here on the Combinations tab, bring up the Combinations window, and because I don't want to be missing too long, I'm going to turn myself back on here, and I don't mean to make you hungry. I don't know what time of the day you're watching this video at, but let's imagine that you are at a restaurant and you order a meal and they tell you that your meal comes with a choice of 2 side dishes. So you're allowed 2 side dishes with your meal, and how many ways can we pair 2 choices from this selection of 4? We have onion rings, we have French fries, we have a side salad, and we have some breadsticks. So here, the order does not matter, because the order in which you order your sides doesn't make any difference. You might select a salad and then onion rings, or onion rings and a salad. You end up with both for your meal. The order doesn't matter like it did when you're setting a combination on a lock. So here, instead of permutations, we use combinations because the order doesn't matter, and we use a notation that looks very much like what we just saw. But instead of a P, we now have a C for combinations. We still have this N for the total sample size or population, and R are the numbers that we're selecting from that population. So N, number in the population, R is the number selected. In this case, we have 4 possible options, 4 different side dishes in our population, and we want to select 2 of them. We could work this out in the long form, where we have n factorial over n minus r factorial times r factorial. And we can then substitute the values that we know to exist for n and r. And I've done that here on the side for you, and maybe I'll just zoom it in just a little bit more so that we can see the details. I'm going to slide it up a little bit. There we go. And in this case here, we can see that we have 4 factorial over 4 minus 2 factorial times 2 factorial. We can do the 4 minus 2, and we know that that's 2 factorial times 2 factorial. And on the numerator, we have 4 factorial. If we take those and we work them out, 4 factorial gives us 24, and 2 factorial times 2 factorial gives us 4, and 24 divided by 4 gives us 6. We can work these things out in long form, but we also have a built-in function in Excel that does this for us. And I'm just going to click on the cell, and we can see that there's a function called combin, C-O-M-B-I-N, and we provide n comma r, so 4 comma 2, and it does the calculation for us. If order did matter, then we could, instead of combin, we would use permute and put in n comma r, and we would get the number of permutations. So if it mattered which order you ordered your sides in, for some reason, but it doesn't. But in some real-life scenarios, like our combination lock, it does make a difference. Then we want to make sure that we're using permute and not combin. And go back to this layer here. So just if we look at, this entry on the right-hand side, we can see that we have permute 10 comma 3, because remember, we have 10 possible values and we're choosing 3 of them. This, when order does matter, is the way to get at a permutation. So it's really important to know whether or not the selection order matters or it doesn't. If it does, we use permute, If it doesn't, we use combin. We can work them out in the long form, and the equation is given. It's given here for combinations, but not for permutations, but they're available in the lecture notes and in our slides and in your textbook. But you can always work it out in long form and then work it out in the short notation to make sure that you got it correct. Go back to the combinations here for a second. You might be saying, well, how do you calculate factorials if I'm going to do this in long form in Excel? Well, the function for that is also quite simple. It's equals fact, and let's say factorial 4. It should give us 24, just like we have at the top here. And if we wanted to do equals factorial 2 times factorial 2, we should get the 4 like we have over here, and there we go. And now we simply divide the value that we have here in Q15 by what we have in Q16. So we can go in here and say divide Q15 divided by Q16, and we have our answer 6, which is exactly the same as what we got before. So there you go, combinations, permutations, a little bit of food for thought. I'll talk to you again very soon.